In this tutorial, we will start by understanding what is operational database and what is data warehouse. Data warehouse is known as OLAP, whereas operational database is known as OLTP. We will later discuss this in more detail. Let's try to understand what is data warehouse and what's the difference between them. Data warehouse is historical processing of information, whereas operational database is day-to-day processing of information. In data warehouse, we used by executive managers and analysts, whereas operational database is used by clerks, DBAs, and database professionals. In data warehouse, we used to analyze the business, whereas in operational database, we used to run the business. Data warehouse focus on information out, whereas operational database focus on data in. It's all about historical data in data warehouse, and operational database is current data. Summarized and consolidated data, whereas in operational database we have raw and detailed data. We can do custom queries in data warehouse, whereas in operational database we do predefined queries. In data warehouse, we have queries process large amount of data. In operational database, we have queries process small amount of data. Data warehouse is partially denormalized schema. Operational database, whereas is normalized schema. Now let's try to understand data warehouse model. Complete warehouse in one unit. It collect all information about all subject in an organization. When we talk about organization, we basically talking about wide data integration. It got systematic solution, minimizes integration problems. It's expensive, takes long time to develop, but lacks flexibility. Now let's see the data warehouse diagram. Like we said, it's for analyst, for executive. We have large amount of data. We can process queries. So how does that work? So we have operational database over here and we have external sources. Extract clean data, load, refresh. It's coming in the data warehouse. We got metadata repository, we got administration, we got monitoring. We also got bottom tier, which we call data warehouse server. So we divide this in three sections: bottom tier, middle tier, top tier. Middle tier got OLAP because we got OLAP servers. Once the data is processed, the output goes for analyst, query report, and data mining in the top tier. Now, what do we mean by data marts? Data marts are small data warehouses. It's a part of a data warehouse specific to one of area of the subject. For example, sales, product, customers. In data mart, data warehouse typically comprises a number of data marts. It's flexible, low cost, quick to deploy. It can lead to an integration problem. Now, what do we mean by dependent versus independent data mart? So we have two data marts over here. In this one, we getting load into one data warehouse and that's going to data mart and we have end user. Whereas in this one, we have load coming into all data marts and that getting transformation and then it's going to data warehouse and to end users. It's also going directly from data mart to end user as well. Now the third one we should discuss virtual warehouse. In data warehouse model we have virtual warehouse. It's a set of views over operational database. It's easy to build and require access capacity on operational database server. What do we mean by metadata repository? Each data warehouse also has a metadata repository. Data that define warehouse objects. Description of data warehouse structure including the warehouse schema, views, dimensions, hierarchies. Operational metadata including data lineage. Mapping from operational environment to data warehouse. Now, what do we mean by data model for data warehouse? Data model is multi-dimensional model. It's got facts, measures, dimension which represent cubes. What do we mean by facts? Facts are events of interest in one model, sales, shipment, room, reservation. Measures are quantity, describe the facts. The revenue of sale, quantity of items sold, the quantity shipped, number of nights the room was booked. Measures organized into dimension, discrete alphanumeric attributes that all represented by a cube. This is a cube. For example, you have product, you have store, and you have date. Cube is three-dimensional. Now let's see the star schema. Most common modeling for the data cube data model is the data warehouse. Large central fact table linked to a set of smaller dimension table. For example, we have time and we have dimension table. We have sales, we got fact table. We got item, we got dimension table. For location, we got dimension table. For branch, we got dimension table. So your fact table connects to all your dimension tables. In fact table, I got time, I got item key, I got branch key, I got location, dollars, and unit. If I see my dimension table, I got time key. If you see all stuff showing in your fact table will be showing in your dimension table on top. And then what is time underscore key? In this, I got stored data, day of the week, month, quarter, year. For item key, I got item key over here and I got item name, brand, type, supplier type. Then I got dimension table for location. So location underscore key, which will remain the same because it comes from the fact table. Street, city, province, country. For branch, I got branch underscore key, which will remain the same, branch name and branch type. So fact table linked to set of smaller dimension tables. Now, how to build a data warehouse? So, for that, we will ask how to integrate data from multiple sources into one well structured databases. We can do that by relational databases, spreadsheet, flat files. After that, we will extract, transform, load. We call this ETL process. And we can use Hadoop, Spark, or Storm. For that, we need to data extraction, we need data cleaning, we need data transformation, we also need data loading and refreshing. So, what is data extraction? Data extraction is gathering data from multiple sources. Data cleaning is finding and correcting errors in data. Data transformation is converting to warehouse format. Data loading is summarizing, consolidating, checking integrity, building indices and partitions. Refreshing is updating from data sources. Now, in the end, let's see the ETL, Apache, Storm, Spark, Hadoop. So these are the one which you will can use to build a data warehouse. So we have Dundee database, we got reports, Edinburgh database, we got spreadsheet. In Aberdeen database, we got raw information. So this is all getting processed in ETL and that's going to data warehouse.